Sure. So, hi. I would like to thank FOSS for giving me this stage to talk about NeST. I know it's a Sunday afternoon after a pretty hefty and tasty lunch. And the previous speakers have done well to keep us all awake. I hope to continue the same. Hi, I'm Narayan from the NeST team. NeST stands for Network Stack Tester. And the NeST core team consists of 5 people: Shantanu, Dhanashekar, Leslie, Mohit, and myself. And we are from the National Institute of Technology, Karnataka, or NITK, Surathkal. So, while performing network experiments, that is, if you tomorrow, let's say, come up with a new TCP protocol, which you think would be faster than the existing ones, maybe in all cases or in some specific cases, you would like to experiment this and find it out before you actually put it out in the world, right? So instead of, one way to go about it would be to set up physical test beds. That is, you actually have a bunch of computers which are connected to each other, which have a specific latency and a bandwidth between them, and then you perform your experiments. But it is pretty obvious that this kind of a setup would be pretty costly. It would consume a lot of time to set up, and also it would be very hard to reproduce by someone else. If they had to do the same thing, they'll have to build the whole setup by themselves again if they want to try it out in a different part of the world. So a good alternative to this is Linux network namespaces. So network namespaces is a Linux kernel tool which helps in isolating only the network environment through virtualization. So this way, instead of setting up actual physical systems, you can have the setup done inside your system where you can have multiple nodes connected to each other. Again, you can set up latencies and bandwidth and you can perform your experiment. So this would be very scalable when compared to these physical systems. But however, even in this process, it is quite time consuming, error prone, and cumbersome to do these process too. So in order to resolve that, we came up with NeST. NeST is an open source Python package that helps in simplifying network experimentation. Basically, it is a Python wrapper around all these Linux kernel tools, and thereby you would have to use only one single Python library, and using that you can use all these multiple Linux network tools and you can run your experiments. The user would then have to master just one single library instead of mastering all of these, and thereby it would also reduce the learning curve of a newcomer. They could concentrate more on the core networking concepts rather than concentrating on learning the tools. So what all can NeST do? So NeST provides APIs for you to build a virtual topology inside your own system. And once you have built this topology, you can set up latencies and bandwidth between these topologies. And the routing in this topology can be done either manually or it can be done using existing routing protocols that have been already implemented inside NeST. And you can configure a flow from one node to another. You can set the time for which the flow should be there, and you can run the experiment. When the experiment is running, in the background, NeST captures the data on each of these nodes, and it readily builds graphs for you, and it also gives you the data in JSON format so that you can use it later for any other purposes. Maybe you want a comparison with a previous experiment, or you want to plot graphs in your own style. So for that, you can use it later. So here is an example. I hope it's visible. So here is an example to show pretty much what NeST does. On the left-hand side, you can see the code written in NeST. And on the right-hand side, you can see the code written in Linux kernel utilities. And basically, this just has two nodes which are connected to each other, latencies and bandwidth set, their addresses are set, and for 10 seconds, you are sending traffic from one node to the other. You can see how simple it looks in NeST and how it looks in Linux kernel utilities. NeST does use this internally, so in the end, you would get the same functionality. It is just that for a person to code it up, this would be much simpler. And note that on the left-hand side, you would also have folders created for you readily, the data finally in a JSON format, and the plots for you created. On the right-hand side, that is still pending, but even without that, this is how they compare to each other. And here is a comparison of NeST versus NS3, how accurate it is. So we ran TCP BBR, which is the latest TCP released by Google, and we compared how NeST compares to NS3, and you can see that the accuracy is pretty good. And for the network enthusiasts here, you can see what all NeST supports. NeST supports point-to-point and CSMA networks. That is, we support LAN also. And your addresses can be either IPv4 or IPv6. You can build any of them. We have congestion control algorithms. We have Linux queuing disciplines. And like I previously said, the routing can be done automatically. That is, once you build the network, once you can use either RIP, OSPF, or ISAS. These are some well-known routing protocols. And you can use this for routing to happen in your network. And we also have MPLS, and we also have recently added applications of IoT, application protocols of IoT. And moving on to the journey of NeST. So NeST started off as a course assignment. So in the core members, you would have seen Mohit P. Tahiliani. He was our professor. He gave this as a course assignment to us. The rest of the core members are the people who took up that course assignment today. And yeah, so these experimental evaluation of network protocols was happening in our college, and frequently they would have to write these complicated scripts as I showed you previously, which was on the left side. And this was a very tedious process, and they had to do it multiple times. So we thought of an alternative so that this process can be simplified for our own users. It started off with simple methods, but slowly it grew, and we saw that this can be used by others also as a common tool to simplify experimentation on networks. And it has been 2.5 years since its inception. And I'm proud to tell that we have 50 plus contributors, most of who are students. And we have extensive documentation in our website also. I would be providing the link of the website later. So we have extensive documentation, and we have 75 plus examples in our repository. And there is a lot of comments even in those examples. So we have comments for each line telling what the program, what this line of the code would do. So we have ensured that a new user to NeST wouldn't have to spend a long time. They would have to go through some basic examples and learn all of them. Later, as and when they need something, if they go through the example, that is all the learning that they would require. And where is NeST used today? NeST is today used in the industry. Some companies have used it for their research purposes while making new features. And though I cannot disclose which companies are using them. And it is also being used in academia. That is, some research papers have used NeST for their experimental purposes. And to refer to those papers, you can see the citations that the NeST paper has. And it is also being used in some universities where they're using NeST to teach students networking core principles with a hands-on experience. So while you learn networking, it's good to also have some experiments and learn with and have a hands-on experience with it. So it's being used in some universities for that. So what are the future plans of NeST? NeST plans on adding BIRD. If you're not familiar with it, BIRD is also another routing protocol which is being used a lot. So we are also adding this to NeST. We are also adding nuplot. So many researchers are used to using nuplot, and they might not be familiar with Python's matplotlib. Hence, we thought we'll add nuplot also to NeST so that a user can work with something they're familiar with rather than learning a lot of things, which is what the main aim of NeST was. We have also added MQTT. That is an application protocol for IoT. That was added. We are working on adding that. And wireless networks, it was supposed to be merged day before yesterday, but there were some issues. So wireless networks will also be added pretty soon, and you'll be able to test Wi-Fi routers and moving stations and all that pretty soon in NeST. We're also thinking about adding a user interface, but there hasn't been any work done on this. And we welcome anyone from the open source community who can contribute to this user interface. Or there are also a list of issues or upcoming features that we want to release in NeST. We also have tags for newcomers stating that this is a good first issue. So you can pick that up and you can do that and you can learn and get into NeST. And these are some of the important links for NeST. This can remain on the screen while if anyone has any questions, they can ask about.
Yeah, so how is NeST different or like better than NS3?
That's a good question. So NS3 is also for anyone who is not familiar with it. NS3 is also an open source tool, but NS3 is a simulator and NeST is an emulator. So how this changes is, in NS3, everything is built in C and it is built from the scratch. So it is basically imitating anything that a network would do. But what we do in NeST is that we use Linux network namespaces. So what this does is, it isolates, like you would have seen with, this is just namespaces, it just isolates the networking part of it. So let's say tomorrow Linux introduces a new TCP or something which is the default TCP. So tomorrow NS3 would have to add that feature also to their code. But since we are just using what is there in the Linux kernel utility, tomorrow when Linux does some changes, it is already present inside NeST because we are using what is present in Linux.
Yeah, I would like to know more about limitations of NeST. Can I emulate a more complex network with, say, 30 or 100 of nodes?
Sure. So the limitation would come up with your system. So like I explained, we are virtualizing only the network part of it. Let's say your system is not built to handle 30 different nodes or 40 different nodes. That is when a limitation of NeST would come up. So we have run projects where we needed 30 or so, but we couldn't run it on our own system. So we ran it in a server, and hence we were able to resolve that issue.
A follow-up. Do you have any roadmap of letting NeST work across, in a more distributed manner, like to use multiple systems altogether?
As in, what exactly in a distributed system would you have to test?
I mean, like you set up NeST in 2 or 3 systems and then use their resources combined to have a more complex network.
No. Currently, we haven't done work on that. Okay. Our main aim of NeST was that there shouldn't be multiple systems. It was for people who can't afford to have multiple systems and servers set up, that they can test it in one single system and have multiple virtual systems present inside that. Okay. So we haven't exactly worked on that.
Thanks. This is interesting. I'll definitely check it out.
Thanks.
Yeah, so really cool project, first of all.
Thanks.
So I have 2 questions. First one is, do you plan on providing some visibility into packet captures? Can we use Wireshark or something to check out which packets are going back and forth?
I love that question because we just recently added that also.
Great, okay.
We added T-Shark.
Right.
And we provide, so we have some user-friendly APIs also for some commonly used flags. So we have them. And apart from that, you can use any feature that is there in T-Shark. You can use it in NeST, and we have the packet capture facility also. So your files would also be present in whatever format you want them to be present.
Oh, great, that's awesome. And my second question is, how much of each node's behavior can you control? I got a very brief look at the code sample that you'd shown. So is it possible for me to emulate something like different failure modes, or is it possible for me to emulate, like a distributed system running a consensus protocol? So, like, do you have that much control into the behavior of each node is my question.
So what you can control in a node is only the things which come in the networking part of the Linux system. But apart from that, for failures, we do have packet failures. We have a drop rate that you can emulate. So maybe 10% drop rate, so every 1 packet out of 10 packets is dropped. Or you can also have packet reordering also set up. We have all these features, but then inside a node, you can only control things which come inside the networking part of the Linux kernel. Only that part of it you can control. Anything else if you want to control, that would change it for your whole system, not just for inside the nodes.
Great, and one last follow-up question. So this tool is written in Python, right? Yeah. So my inherent contention with Python is that you have the global interpreter lock, which makes it a lot more difficult for you to parallelize your code and essentially be able to take advantage of vertical scaling on the same machine by means of multiple threads. So do you have any plans to move to a more system-side language to do this? Or are you looking for someone who's probably willing to try that out?
No, but what we already have in NeST is that if you want to parallelly run experiments inside on a topology, we have a method where you can create multiple copies of them. So basically what you would tell is run experiment 1, 2, 3, 4. But inside NeST, what would happen is we create multiple copies of the same topology and we run each experiment on each of them. So this way, let's say your experiment itself is for 30 minutes and you want to run 4 experiments with 4 different parameters. You wouldn't have to wait for 2 hours. it would create 4 copies of the same topology and run the experiments on those 4 copies, thereby saving you 1.5 hours in time.
Very cool. So this is Python's async, is it?
Yeah, the internals, I wouldn't be able to get into that, but
Right.
we basically create multiple copies of it and then we run it using threads.
Right. Very cool. Thank you.
Thanks.
Is there any roadmap to bringing support to other operating systems as well, or?
Other operating systems as in Windows. Windows doesn't provide us with this functionality, but yes, we could try expanding into Arch Linux or something along that lines. But right now, no. Yeah, we would like to expand into that. We are also providing a Docker, which you can just use and run this on maybe your VM or something along that. But you would need sudo access for that.
Any more questions?
Thanks. Thanks.